Welcome to Pre-Math. In this video, we have got this circle with the center O such that this diameter AB and this chord CD intersect each other such that we get this angle 45 degrees. And furthermore, this segment CE is 16 and this segment ED is 8 units. And now our task is to find the radius of this circle. Please don't forget to give a thumbs up and subscribe. Please keep in mind that this figure may not be 100% true to the scale. Let's go ahead and get started. And here's our action plan. Now let's recall the intersecting chords theorem. According to this theorem, if two chords intersect in a circle, then the products of the measures of the segments of the chords are equal, as you can see in this diagram. As you can see, we got these two chords that intersect each other, and as a result we got these segments A, B, C and D. So therefore we can write A times B equal to C times D, as you can see in this equation. Now we are going to apply the very same theorem in our case. Over here we can see we got these two chords A, B and CD intersect each other such that we got one this segment which is 16, the other segment is 8, and the other two segments are going to be AE and EB. And now our task is going to be find the value of this segment AB and the value of this another segment EB as well. And here's our very first step. I have drawn this perpendicular, and we can see that this is our radius. Let me go ahead and call this radius as lowercase r. We know that this is going to be our radius lowercase r, and likewise this is our radius lowercase r as well. And here's our next step. Let's focus on this green shaded triangle. We know that this angle is 45 degrees, this angle is 90 degrees, so therefore this angle has got to be 45 degrees, since the sum of angles in a triangle must be equal to 180 degrees. Let me go ahead and call this side length OE as x units. And now let's recall this special 45, 90 degrees triangle. So this is called an isosceles triangle, since this angle equals to this angle. So therefore this side length must be equal to this side length. If I call this side length x, then this side length is going to be x as well, and this third leg is going to be x times square root of 2. And if you are not sure how we got this third leg, we can use the Pythagorean theorem, a square plus b square equal to c square, where this longest leg is going to be a c, this side is a, and this side lowercase b. Let's go ahead and plug it in this Pythagorean formula to show you. A in our case is x, so this will become x square plus b is x square as well, equal to, in our case, c is x times square root of 2 and then whole square. So the left hand side is going to be 2x square, and over here on the right hand side, if we take care of this thing, that's going to be 2x square as well. So therefore this is a true statement since both sides are equal. So therefore in our this right triangle, this side length is going to be x units as well, and this third leg is going to be x times square root of 2. And now let's make an observation. We know that this segment OE is x, and this segment OF is x as well, and we know that both of these are the radii of the very same circle. So therefore this length is going to be equal to this length. That means this side length equal to this segment. So that means this sector is going to be congruent to this sector. So therefore this side length which is 8 is going to be equal to this side length 8 as well. And we know that this whole segment is 16. So therefore we conclude that this segment EF is going to be 8 as well. And we also know that this segment EF is x times square root of 2 as well. So therefore I can equate this x times square root of 2 equals to 8. Let me go ahead and write down x times square root of 2 equals to 8 units. Let's go ahead and divide both sides by square root of 2 to isolate x. This is gone. So therefore x turns out to be 8 divided by square root of 2. Now let's go ahead and rationalize the denominator by multiplying by 2 and dividing at the same time by square root of 2 as well. And here at the denominator, square root of 2 times square root of 2 is going to become square root of 4, which is equal to 2. So therefore we got x equal to 8 times the square root of 2 divided by 2. That means x turns out to be 4 times the square root of 2. So thus this x value turns out to be 4 times the square root of 2. And now we know that this is our radius lowercase r and this is our radius lowercase r. So that means this whole segment AE is going to be r plus this x, which is 4 times the square root of 2. And this length, this segment EB is going to be r minus this x value, which is 4 times the square root of 2. And now let's recall the intersecting chords theorem once again. We are going to apply now over here. Let me go ahead and call this segment A, this segment B, this segment C, and this segment D. So let's go ahead and fill in the blanks in this formula. So A in our case is r plus 4 times square root of 2 times B is r minus 4 times square root of 2 equals to C is 16 times D is 8. And now let's recall this famous identity. A plus B times A minus B could be written as A square minus B square. We are going to apply it on this left hand side. So therefore left hand side could be written as r square times 4 times square root of 2 whole square equals to, on the right hand side, 16 times 8 is 128. Let's go ahead and simplify the left hand side. R square minus this thing is going to give us 32 equals to 128. Go ahead and add 32 on both sides. This is gone. So therefore r square turns out to be 160. Let's undo this square by taking a square root on both sides. So therefore our radius r turns out to be approximately equal to 12.65 units. So thus the radius of this circle turns out to be approximately equal to 12.65 units. Thanks for watching, and please don't forget to subscribe to my channel for more exciting videos. Bye.